Hello. The purpose of this is to review for our test that's upcoming. You can see all of the different topics that will be on the test. Today, this review is going to cover the exponent rules and then also the applications. So for this, what I would recommend doing is trying all of these examples on your own and then coming here if you have a question on one of them or want to hear it out. So again, try these on your own first. Give yourself a chance to kind of see if you know it or not, and then come to this video to see an explanation of things. So for the first one, we notice we have the same base here, so we're going to leave the base as 4, and you're going to take and you're going to add your exponents together. So it's going to be 4 to the 5th power. Anything with numbers, you're actually going to evaluate. So if you actually do 4 to the 5th power, that's 1024, and that would be our final answer. For number 2, you're going to take your exponents and you're going to multiply them. That's going to give you 2 to the 6th. When you actually do 2 to the 6th, that's going to end up being 64. For number 3, I noticed 2 sets of parentheses. So what I'm going to do first is I'm going to raise everything in the parentheses to the power. So 5 to the 4th and x to the 4th. And then for the next one, I'm going to do, careful with this one, it's -4 in parentheses cubed and x cubed. So 5 to the 4th, we're actually going to calculate that as 625. And -4 to the 3rd is going to be -64. And so we're going to take 625 and -64 and multiply them to get -40,000. And then x to the 7th when we add our exponents together. Here's another one where we're going to raise everything to the power. So since it's a squared to the 4th, you're going to multiply them and get a to the 8th, b to the 4th, c to the 12th. For the next one, it's b to the 6th and c cubed. We're going to then find the same bases and combine them. When we combine them, we're going to add our exponents. So it's going to be a to the 8th, b to the 10th, and c to the 15th. Number 5, you have to be very careful about what is being raised to the -2nd power. Right now, it's only the x that's being raised to the -2nd power. So the 4 is going to stay where it is. The x to the 2nd, that's the only thing that's going to move down to the denominator. Likewise, for the next one, it's x to the -5th and y to the -1st. So those are the ones that are going to move down to the denominator. And you get 7 over x to the 5th and y to the 1st. Whereas number 7 is the same idea here. The negative exponents would be x to the -2nd and y to the -7th. When they're in the denominator, they're going to move up to the numerator to become a positive. So it's x to the 2nd and y to the 7th over 11. Number 8, the reminder here is anything to the 0 power is going to be 1. And then I'm also going to move y squared down. So it's going to become 1 over y squared. Now, number 9, we're going to have to be very careful. We're going to raise everything to the -3rd power. So it's 2 to the -3rd, x to the -9th, and y to the 24th, because the -8 times the -3 is a positive 24. So before you try to figure out what 2 to the -3rd is, I'm going to actually take and I'm going to move it. So don't actually calculate what that equals. Move it first and then calculate it. So y to the 24th stays in the numerator. Then we have 2 cubed in the denominator and x to the 9th, which means 2 cubed is going to be 8, and everything else remains what it was. So now we're going to get into pretty tricky problems here. So for the first one, we're going to raise everything to the -3rd power. Then we're going to move any negative exponents, and since they're both in the denominator, they're going to move up. It's going to become 8 cubed and x to the 6th, and there's nothing then in the denominator. So 8 cubed is 512. I wrote that backwards, 512, and then x to the 6th. For the next one, we're going to take and just multiply everything. We don't have any exponents here, so we're going to do 2 times -3 to get -6. Then we're going to multiply our a's together. When we do that, we take and we add our exponents. So 2 plus -4 becomes -2. For the b values, -7 plus 2 gives us -5. Then we're going to go through and start circling everything that needs to move. Now, this -6 stays in the numerator. It's okay to have negative numbers, but it's not okay to have negative exponents. So the only things that move are the a squared and the b to the 5th. Again, the -6 stays where it is because it doesn't have a negative exponent. So let's try this next one. We're going to raise everything to the second power. After we do that, we're going to go ahead and move things around. We're also going to simplify our numbers. So 3 squared is 9. We have x to the 4th, and then x to the 8th gets bumped on up, and 4 squared is 16. Which means the only other thing we can do is we can combine our x's by adding our exponents together. So it's 9x to the 12th over 16. For number 13 here, we're going to first raise everything to the -2nd power. Notice how I'm writing -7 here. So -7 to the -2nd. And then c to the 6th, d to the -6th, over c to the -10th, d to the -2nd, and h to the 8th. Now I'm going to circle everything that has a negative exponent. So the c to the 6th and the h to the 8th stay where they are. -7 squared moves down. D to the 6th moves down. C to the 10th and d squared move up. Now I'm going to combine my c's. I have 16 of them. I'm going to combine my d's. I have an extra 4 in the denominator, and I still have 8 h's. And then I'm also going to calculate what -7 squared is. Now, -7 times -7 is 49. If you got -49, please make sure you are squaring that negative sign as well. So if you're using a calculator, you need parentheses around -7, and the squared goes outside of the parentheses. So our last one for our monomial and exponent rules here, we're going to go ahead and we're going to distribute that -3 exponent to everything in the numerator. So you get 2 cubed a to the 6th and b to the -3rd over 16a squared and b to the 4th. Then we're going to take care of any negative exponents, and I'm also going to figure out what 2 cubed is. So 2 cubed is 8. I have a to the 6th over 16a squared b to the 4th, and I moved down 3 more b's. The last thing I can do here is I can reduce my numbers. 8 over 16, I can divide each by 8. 8 over 16 is equivalent to 1/2. My a's, I have 4 extra a's in the numerator. And for my b's, I combine them to get 7. So it's a to the 4th over 2b to the 7th. And if you have a 1 out in front there, that's the same thing. It's totally fine. So the other thing we're going to review here is the applications of exponential functions. So your growth, your decay, and your compound interest. So let's take a look at 15. Arthur is starting a job. He offers a starting salary of $65,000. So that is going to be our initial amount, which in our formula is our A value. The guaranteed pay increase is 2%. That's going to be our rate. But we're going to move our decimal over 2 spots, so it's 0.02. We're looking for how much he will be earning in 12 years. So 12 here represents our time. So this one is a pay increase, which means we are going to be using our growth formula. So we're going to write y equals our initial amount times 1 plus our rate, which is 0.02 to the time. And once I write my equation, all I have to do is type it in my calculator. So I'm going to pull this up here. You write 65,000 and then parentheses 1 plus 0.02, and then you're going to do the caret key. It's looking like that little arrow up key. That's your exponent to the 12th power. So we get this number, and we're going to round it to the nearest penny. So it's $82,435.72. So this is $82,435.72. Let's take a look at this next one. Now we have Tyler investing all of his lawn mowing business from the summer. So you get 9%, and that's a huge interest rate. So that's going to be 0.09. But you see these words compounded and then followed by another word, monthly. So anytime you see the word compounded, you're going to go to your compound interest formula. And monthly tells us our N value. So if something happens monthly, that's going to happen 12 times per year. We are looking for after 3 years, which is your time, how much he's going to have if he invests all 500 of his initial amount. Now in our compound interest formula, our initial amount is our p-value. So we're looking for A equals 500, parentheses 1 plus your rate, which is 0.09, divided by n, which is 12, to the n, which is 12, times 3. So we're going to type this in, 500 parentheses 1 plus 0.09 divided by 12, to the, and I would strongly recommend parentheses here because some of you don't have the same calculator as me, so it's a great idea to use parentheses around that exponent, the 12 times 3. So when we hit enter, we get $654.32. $654.32. So that's our review for our test. I hope it went okay. If it didn't, come in with questions. And thank you very much for listening.